Okay, we'll look at the homework in section 1.2, starting with problem number 1. Determine the next term of the sequence and determine if the sequence is arithmetic, geometric, or neither. Okay, in this case here we got 4, 7, 10, 13, 16. Notice in this case here, if we look at the difference between 4 and 7, that's 3. 7 and 10 is 3. 10 and 13 is also 3. 13 to 16 is 3. So the next term, we'll have to add 3 to the 16 to get 19. So the next term in this particular sequence is 19. Now we want to determine whether that sequence is arithmetic, geometric, or neither. Here, in this case here, we're adding the same number each time. The common difference is 3. So this would be an arithmetic sequence. Okay, so that's problem number 1. Problem number 2, find the 9th term of the sequence. The 9th term of that particular sequence. In this case here, we got -1, -4, -16, -64. Here we're multiplying by 4 each time. So here, 64 times -4 would be -256. So -256 will be the 5th term of that particular sequence. Now, if we multiply -256 times 4, that'd be -1024. That's your 6th term. The 7th term would be -4096. Here I'm just multiplying by 4 each time. The 8th term of that particular sequence would be 16,384. -16,384. And then the 9th term, which is what we're trying to find, is -65,536. So that's the 9th term of this sequence, -65,536. And then the other part of that problem is to find out which formula fits that particular sequence. I can tell that this is a geometric sequence because since we're multiplying by 4 each and every time, it is qualified as a geometric sequence. So here, it will have to be part A, because if you notice the first term is -1, and it's multiplied by the common ratio, in this case, which is 4, times n to the -1, raised to the n minus 1. I'm sorry. So it would be -1 times 4 to the n minus 1, which is answer A. Number 3 is a growing deer population increases 7 animals per year. If the current population is 49 animals, what will it be in 10 years? Okay, in this case here, we're starting off with 49 animals, and it increases every year. Well, 7 animals per year, so it'll be 10 times 7, because we're trying to find out how long what will it be in 10 years. So 10 times 7, which would be 70, so it'll be 49 plus 70, which is 119. So in 10 years, the population will be 119 animals. Okay. All right, problem number 4 is this. Here we're going to find the first 5 terms of the sequence whose nth term is given by the following. -10 n minus 4. -10 n minus 4. In this case, the first term will be n is equal to 1, so that'd be -10 times 1 minus 4. Or -10 minus 4, which is -14. So the first term would be -14. The second term will represent n is equal to 2, so it'll be -10 times 2 minus 4, or negative 20 minus 4, which is negative 24. Then the third term, n is 3, so it'll be negative 10 times 3 minus 4. Negative 10 times 3, that's negative 30, minus 4, that's negative 34. And then the fourth term, that's negative 10 times n, which is 4, minus 4, or negative 40 minus 4, which is negative 44. And then finally, the fifth term, n is 5, so that's negative 10 times 5 minus 4, or negative 50 minus 4, that's negative 54. So those are the first 5 terms of this sequence, negative 10, n minus 4, negative 14, negative 24, negative 34, negative 44, and negative 54. And then finally, number 5, you got these two sequences. Here's sequence A and sequence B. And here you want to find the number of the term in which the geometric sequence becomes larger than the arithmetic sequence. Okay, now here's what I did. For this particular problem, I knew the fifth term in sequence A was 45,400 and the fifth term in sequence B was 729. Now, the common difference in A was 3,400 and the common ratio in B was 3. A was an arithmetic sequence, B was a geometric sequence. So here, from that fifth term, I added 3,400 each time and saw that it was 59,000 at the ninth term. And then for sequence B, I multiplied by 3 each time and saw that the ninth term was 59,049. Notice in this case here that sequence B at the ninth term became larger than sequence A by about 49. So in this case, sequence B is larger than sequence A when you get to the ninth term of that sequence, as you can see here. Okay, so that should be enough to get you started on the homework for section 1-2.